Hi everyone, this is Dani Fuya, CEO and co-founder of Flowhawk, and in today's video I'm going to show you how we have automated the internal operations of our directory. And for those of you that are unfamiliar with a directory, basically you have to spend a lot of time sourcing information in the internet and also migrating this information to your database. We have decided to automate the second part of it, and it was taking us around 1 hour and a half, 2 hours daily, so it's the perfect task to be automated. Before we proceed, I want to be very clear with you. What we are going to see today, it's not an AI agent. This is just an automation. And I'm saying this because nowadays there's a lot of hype about AI agents, and everything it's called an AI agent. In a workflow automation, you can have LLMs integrated, but the difference is that the path, it's always the same. You establish it from the beginning and you know beforehand what's going to happen every time. While when you are working with an AI agent, you are not 100% sure what will be the next action the agent will take. Let me first show you a bit about the directory, and this way you will have a better understanding about the task that has to be done. So here we have the directory, and as we see, we have multiple listings on it. If we go to one of these listings, we see that we have collected a set of information. We have a name, we have a short description, we have a more detailed description, that in our case, this description is very important for the SEO. But also we have some features that the agent has and some use cases where the agent is used. Apart from this, we have also the pricing. In this case, this agent didn't have pricing. And then we have a set of predefined categories that we have decided in our directory. And for each of these categories, a listing can have a predefined set of tags. Finally, we have also classified the listing into whether it's closed source or open source. So before doing the automation, for each of these AI agents that we are listing, we had to go to this form and fill this form manually. Okay, so you can imagine it was taking us around 10-15 minutes per agent. And if you're listing multiple agents per day, this is a lot of time at the end of the day. So in our case, now that we have automated this process, it is just taking us around 10 seconds per listing. For the automation, we will use N8N. For those of you that are unfamiliar, N8N is a Zapier with two big differences. The first one is that it's open source, so you can run it on your PC without having to pay. And secondly, it has AI blocks integrated. So it makes it quite easy to use LLMs. For the LLMs, we will be using Mistral, but you can use any other providers like OpenAI or Anthropic. And here we will be using the experiment plan. Great, so let me do a brief demo of the automation, so this way you see how it works. So on the left side, we have the interface of N8N, and this is what we are going to use to interact with the workflow automation by typing things on the chat. And on the right-hand side, you will see the best agents directory, and you'll see that it's being updated live. In this demo, we will be listing 3 different agents that I have seen. The first one is Luminance. It's a legal AI agent for contract review and contract drafting. The second one is Brainfish. It's an AI agent for customer support. And finally, we will be listing N8N, AI agent for campaign planning. Back in the N8N interface, the only thing that we have to provide to the workflow is the website URL and the image URL of the agent. Let's start by listing Luminance. So let's take the URL from the site and let's type it in the chat. For the image URL, I have been looking for it before and it's here. Cool, let's send this message. And now we have to wait around 10 seconds, and you will see here on the right hand side that we will do refresh once we receive confirmation, and it will be automatically listed. Okay, so see the node was executed successfully, and if we now refresh, it's here, Luminance. Let's have a look at it. Luminance, platform for end-to-end contract management. And if we have a look at the description, platform designed to enhance contract management. It automates contract generation, negotiation. It also talks about the features and the integrations with Microsoft, Outlook, quite good. For the features, we see that it has automated contract drafting, intelligent contract repository, business-wise automation. And for the use cases, automating contract drafting, improving contract compliance, reducing legal bottlenecks. So it seems that the quality of the data generated, it's quite good. For the pricing, it seems that it has not been able to extract the pricing. It happens normally when the agent has the pricing published. It seems it's the case for Luminance. And here the categorization and the tag seems quite solid. It's legal and it's for contract review, and it's closed source. Let's proceed with the following one, with Brainfish. Let's take the URL and let's take this image URL. Let's now wait again a couple of seconds. In the meantime, we can start preparing the next one. So we have here the NYX. Let me copy and paste first the URL of the website. Nice, it seems it's already executed. And it's here. Okay, let me finish pasting the URL here and let's think about Brainfish. Brainfish, customer support, agent for customer support and knowledge creation. It has some features, real-time support guidance, user behavior understanding, multimodal answer engine, end-to-end task completion. And for the agent use cases, automating L1 support, reducing customer effort, understanding user behavior, automating L2 support, providing contextual guidance. So as you see, the quality of the data is quite good. Still, it could have room for improvement. Here we see the pricing, it's free, paid from, wow, $795 per month. Maybe let's check if it's right. Okay, it's right. It seems that it's quite expensive, Brainfish. And then the category, it's customer support and it's a chatbot. Let's get to the last one. The last one is NYX, that we have already prepared it here. Let's list it. Let's refresh here. Marketing agent for high converting ad creatives. It's an AI agent designed to enhance marketing operations. We see that the automation has not been able to detect any pricing, but there's actually a pricing in the page. Actually, if we refresh here, I can give you a first insight of what's happening. As you see, this page has some JavaScript when you are loading it. This is why it's hard for the scripter you use behind the scenes to detect this information. Regarding the category, it has not assigned any tag to this agent. We'll see later why this has happened, and it's something it's done on purpose. We want to be strict when we are assigning tags in our directory. So we want the LLM to be extremely sure that the tag is the proper one. I'll get later into this, but just that you are aware. This is the workflow that we have in N8N, and as you see, it looks quite big. And this is the thing with N8N. It's a really good tool to do fast prototyping, but if you are planning to do more complex projects, it's hard to scale. In any case, this workflow can be divided in three main parts. The first part, it's related to the chatbot interface. The second part, it's related to the part of extracting information and classifying the listing according to this information. And the last part, it's about inserting all this information in the database. This last part will be very custom according to your system. So in our case, we have different tables, but at the end of the day, all the last blocks of the workflow do the same. They just insert the information in a different table. So let's start from the beginning. In the first block, what we have is basically one of these blocks of a chat interface. And the next step is to use an LLM to process this input. We can have a look at the prompt. Basically, the prompt is your task is to collect information from a user, extract website URL and image from user message. The interesting thing here is that we are using a structured output parser. This is a functionality of this LLM block that it's quite useful. And what it does, it allows you to force the LLM to output the data in a structured way. And this is following a JSON schema. I will not get in detail into the JSON schema. You can look it online. And actually, you don't need to learn it yourself. You can use an LLM to generate these type of schemas. Here, what we are telling the LLM is that we want an object, and the object must have a website that would be a string, and an image URL that will be a string. In the LLM block, we can connect a chat model, and we see that here we are using Mistral Small. It's a model that is similar to GPT-4o Mini. You will have to create a credential here, and here insert the API key that you obtain in the Mistral dashboard. Before we proceed, I have run again the execution to list Brainfish, so this way we will be able to see the inputs and the outputs of each block. Immediately after the LLM output, what we have is a block that modifies a bit the structure of the output. The output of the LLM, it's an object with a key output, and here we are applying a custom code to remove this key. So this way it's easier to use these inputs in the following blocks. In the end, the data is the same. So immediately after this block, we do an HTTP request, and here we are calling the website, and we are getting the HTML. If we copy this HTML and paste it in a text editor, we'll see that this HTML is quite long. It has a lot of data that we actually don't want to send to the LLM because it contains all the tags, like scripts, CSS classes. This is going to use a lot of tokens. What we are going to do next is to just keep the tags of the HTML that we want. And for this, we have created here another custom code that basically what it's doing is removing the HTML elements that we don't want and that are redundant. You don't have to do this code yourself. You just go to ChatGPT and just tell him to do this code for you. And here what we see is that the data, if we copy and paste it, it's more human friendly. All the HTML tags have been removed. Still, it's quite hard to be understood by a human, but this is more than enough for an LLM to extract information. With this output, we are going to create 5 different LLM tasks, and each task is going to be responsible for extracting one piece of information from this website data. Something that we are doing here and that you will see quite often is that we have decomposed a big task into smaller subtasks. If you are doing a big task, what I've seen is that the accuracy is higher if you are decomposing tasks and using smaller models rather than trying to achieve one big task with a bigger model. If we have a look at the first block, we are going to extract the name of the AI agent and also to detect if it's open source or closed source. So if we have a look at the prompt, basically we have a small introduction where we are telling the LLM that it's an information collector and that it must extract the website URL, and also if the solution is open source. And something very important here is that we are telling the LLM to provide a confidence score of how sure it is that listing is open source or closed source. And it's important to do this because if you just tell the model to tell if it's open source or not, in the vast majority of cases, it will say that it's open source. Here, we'll use this confidence score to later determine whether it's open source or not. We are doing few-shot strategy prompting. That it consists in providing a set of examples for the model. This way, it's easier for the model to understand the type of format that we want. Without the few-shot example strategy, the model was providing names that were large. For example, imagine that chat thing, the first example provided here. In the title, it has chat thing AI for chat. The model was thinking that this was the full name. It could be that this was happening because the model is not a big model. The good thing of using few-shot sample is that you can increase the accuracy of your system without necessarily having to use a larger model and consequently more expensive model. Here at the end of the prompt, we are dynamically sending the data that we received from the previous code. This is the final prompt that was provided in this block for this execution. And here we see the output. We see that the name is Brainfish, that it's not open source, and it has a confidence open source of 0. 0 means that it is pretty sure that it's not open source, while the closer to 1, the more confident it is that the agent is open source. The important thing here is the output structure. We are telling that we want a name, an open source, and a confidence open source, and we are providing the type of format for each of these fields. Let's go now to the next block. We are extracting the short description. And again, here we are using a small introduction telling the LLM that it has to extract a short description. And very important here is the content guidelines. You want to make sure that the description format of the model really matches the format that you want in your website. This is why we are telling him to not use AI-powered words. We only want the short description, thus we want a maximum of 8 words. And here we are providing examples of listings that we have in our database, so that it is able to understand what kind of format we want for our short description. If you have previously done the job manually and you have some data of the final output that you expect, it will be easier for you to achieve the type of quality that you expect. The output for Brainfish was customer support agent for reducing effort, so quite good. And here again, the short description, we just tell that we want a short description key with type string. For the long description, it will be quite similar. A small introduction telling the LLM to extract a long description. We are using a few-shot example strategy, and we're providing dynamically the data. You can have a look at the prompt. It's just quite straightforward. Let's now move to the features task. And here, the problem that we were having is that we want to list a maximum of 8 features and a minimum of 4. And if you don't set these requirements to the LLM provides a lot of features, and these features can be repetitive. So it's very important, as before, to force the type of format that you want. If we have a look at the features, it extracts the features the way we want. For the features format, we are telling that we want an array of features, and each item inside the array should be a string. Cool. And if we proceed, finally we have the use cases extraction, and this is similar to the previous prompt, just changing a bit the examples. Okay, so now that we have all this information, we are going to use a merge block that it's called in N8N. And what this block does, it merges all the outputs from the previous blocks. With all this information, we can proceed to insert the listing into the database. If we follow the flow, we see that here we are doing some action before inserting the type of source of the listing into the database. So we see here that we have a merge block, and if we follow the flow, we see that this merge block comes from this custom block that is about extracting things from homepage. This block, what it's doing, it's taking the HTTP request that we did in the beginning that contains all the HTML of the website. And here, with all this HTML, again, we have used ChatGPT to create a custom code that extracts all links from the HTML. It's looking for the A tags in the HTML that belongs to links, and it's just creating an array of items where each item contains the URL and also the text that is inside the URL. These links will be used for two main purposes. First one, to extract the GitHub link of the agent if it exists, and also to extract the pricing link. So this way we can insert in our database information about the AI agent pricing. We'll now proceed to see what this set of blocks do. Just before we start, as you'll see, it doesn't make much sense what we are doing here. What we are going to do is just to extract the GitHub link of the listing if it exists. It took me a while to figure out, but just in case you're also using N8N. So the issue is that if you're using an if-else block and you're connecting the output to the merge block, you should always make sure that this branch it's providing an output. And it can be empty, but you have to make sure that you have this setting over here enabled. Otherwise, if you don't do this and you connect this if-else block to the merge block, this flow will never run because it will keep waiting for an input to be received here. Okay, so let's start. Here we are just merging the links that we got from the custom code with all this information of the listing. And here in this if-else block, we are trying to detect whether the listing is open source or not. Okay, so we see the open source, it's false. So here, the false branch will be output all the links, and the true branch will not output anything. In this case, it's not open source, and we don't need to extract any GitHub link. It could have been good just to end the flow here, but since for the listings that are open source, we want to extract the GitHub link, and we want to make sure that it's inserted in our database, we have to do an extra step, where here we are using a custom code to extract from all the list of links the link that contains the GitHub URL. And here, if the GitHub link contains the github.com word, we just proceed. In any case, we are merging three items. The first one is the GitHub link that we are getting from this block over here, all the structural information that we extracted, and also we are getting the website and image URL from this block over here. And here the information depends heavily on your database schema. But in any case, as you'll see in our main table, we have a Slack column. This is why we are taking the name of the listing, and we are creating a Slack from this name. With all this in mind, we get to the first action in our database. We will have to connect your Supabase DB, just creating a credential. We are creating a new row in our table listings. As I've said, this depends on your database. And we are inserting almost all this information over here in each corresponding column of the table. We have a separate table where we link the listing ID that will provide this table that we see actually over here with the features and use cases of the agent. As you see here, I'm just inserting the Slack, website URL, when it was created, when it was updated, names or description, log description. The interesting thing is that despite we are having the image URL, we are not inserting the logo URL here, and this is because we have our own storage database. So what we are going to do in the next steps is to download this image from the URL and upload it to our storage bucket. and then we'll use the public URL of our storage bucket. Okay, so now we have the ID of the listing, and we can now proceed to insert the remaining information in the different tables and link this information to this ID. If you go here, we first add the use cases, and in this merge block, we are just merging the information of the listing with the listing ID that we got from this Supabase block. And now, since we are inserting just use cases in the use case table, we'll just clean a bit our data, and from all this information, we'll just get the use cases, and for each use case, we'll append the ID of the listing. As you see, we have for each of these use cases one item, and together with the ID of the listing, and this will facilitate our insert in the database because we need these two items. Okay, so in this table here, we are just creating a new row in the listings use cases table. That is how we call this table in our database. And we just insert the listing ID and the corresponding use case. And here we see the result. We have performed all these inserts in the database. If you understood this logic, I said it's not that trivial because it depends on your database. We'll do this for each of the remaining pieces of information. For the features, we again merge the information of the listing with the listing ID. So actually, you'll see it here. We have two inputs. Input 1, the structured data from the listing, and input 2, all the Supabase information resulting from creating a listing in the listings table. We clean a bit the data here, and we just pass to the last node the feature name and the listing ID. And here in the listings features, it's a table we have in our database. For each of these items, we take the listing ID and we insert the feature name. Let's now proceed to insert whether the listing was open source or not. In our case, we have different types of listings. We have a listing that's closed source and a listing type open source. So what we are doing here, we have a table called source types, and we know that this table has a slug, and we want to obtain the ID of the item closed source. Here, since the listing is open source, we have not called this node, but if the listing would be open source, this true-false branch would be true, and we'll connect over here. So in this case, this branch over here has not been executed. Here we merge the open source type that we got from the source type tables with the listing ID. And now, so we have the open source ID for closed source, and we have the listing ID. So in the end, with these three inputs, we can proceed to tag the listing as closed source. And here we just do a double check, just checking that again the open source ID exists, just to make sure that this operation over here was correct. And finally, we are inserting in the listings source types a new row where it consists of the listing ID and the source type ID, that in this case it's the closed source one. Okay, this ID, it's related to the closed source. And here we see the resulting operation. The listing ID inserted and the source type ID inserted. So till here, what we have done is we have inserted in our listings table some general information of the listing. We have obtained a listing ID, and then we have used this listing ID to insert into our database the use cases in a different table, the features in another table, and then the source type of the listing in another table. Now we have more actions remaining. The first one is to insert in our storage bucket the image of the listing, so we can later use it in our site. We have to insert also the tags assigned to the listing, the category to the listing, and then the pricing. So there are 4 more actions to be done here. Let's start with the pricing. So for the pricing, this is done over here with this section at the bottom. From this array of links, what we are going to do is we are going to use an LLM to extract a pricing link if it exists. And to do that, we are just telling the model that his task is to extract the link that contains pricing. And we are telling the model to provide 2 things. First one, if the pricing exists as Boolean, and the link itself. Here actually this would be redundant, it would be not required, because as you see here, we are using again an output parser, and here we are telling the LLM that we want a pricing exists key with a boolean, true or false, and a link in type string. We'll use the Mistral small model that we like so much. We saw that the output was the pricing exists true and that the link was pricing. And here we are just doing an if-else block. Here we can have two scenarios. It could be that the page has a pricing link in the home page, or it could not. So if the pricing link exists, we are fetching and extracting this information. On the other hand, if there's no pricing link in the home page, we are going to extract the pricing information from the landing page. That again, it could be that this information is not even there. If this happens, nothing will be inserted in the database. This could be further improved. Some websites, they have a pricing link, but it's not visible on the homepage. A better way to do this would be to try to fetch the sitemap of the website, and from there trying to extract the pricing link that very likely it is there. Okay, so let's proceed with the first branch. This field pricing exists, it's true. And we proceed with this custom code. We are doing again a bit of formatting, because if you try to fetch the pricing, it will fail. Because this is a relative path, what it means is that we need to merge the URL of the website with the relative link. Okay, so in the end, this is what this code over here is doing. And here we obtain the final complete link. This code is a bit tricky because there are plenty of edge cases over here. It could be that the link extracted has some query params. So here we are doing some kind of validation. Okay, so then we'll use this output link over here and to fetch it and extract a huge HTML that we will have to filter. We are using the exactly same block that we have used in this code. But in any case, here the pricing, we were able to extract it correctly. Here we fetch, here we do the filtering, and now we pass all this information to the LLM, and here we are telling him that his task is to extract monthly pricings. Something particular in our case is that we want free tires to be inserted in the database as 0, so this way later we parse it in our front end and we show the listing as free. So quite good. Here we see the output that we want, and here we are using Mistral small, and the interesting part here is the output parser. We are asking for an array of prices, and each pricing should be a string. In the merge block, this is a bit different from the one we had here, because here we want this merge block to be executed all the time. This is why here we have in the settings that we want to always output data. But here, on the other hand, we only want this branch to be enabled when this branch is not enabled. In this case, for this if-else block, we do not want to have this setting enabled. This is just very related to the N8N tool, but just that you are aware. And here in our database, we have a table where we create a new entry for each pricing. So here we merge again the listing ID with the second input, that it's these prices, and the output is this. So in the end, what we're going to use is these prices and this ID. We clean it again, so we have this array of pricings and the same listing ID. And here, for each one of these items, we insert in the pricing tires table the listing ID and the pricing. Now that we have the pricings in the database, let's proceed to insert the categories and the tags. So the category assignment and the tag assignment will be due in this branch over here. The first thing we'll do is we are going to fetch the categories in our database, and then we'll provide these categories to a model together with the information of the listing, and we will tell the model to classify the listing within one of our categories. And once we have this category assigned, we will proceed with the tags. For the tags, we have tags that are category specific. We are going to fetch the tags for the category that this chat model has provided us. And from there, we'll use a second model where we will input the information of the listing and the tags for the category. And then we will tell the model to provide the tags that better fit this listing, and also a confidence score for the tags. The reason we are using this confidence score is because the LLM many times feels forced to assign tags even if there's no perfect tag that fits the listing. And finally, here we are doing a last sanity check where we confirm that the tags provided by the LLM are the real tags that we obtain in our database. Okay, let's have a look at it. So I said, we come from here where we have the information of our AI agent. The first thing we do is here we have defined a function in our database that returns the different categories that we have together with the IDs. And here we'll be merging both the information with the categories. And now with all this information, we are ready to tell the LLM to try to assign a category to the listing. First of all, we are explaining the task to be done, that we need the most appropriate category. And here we are telling to also provide confidence scores, because in the end, the LLM will provide a lot of categories and we'll just take the category that has the highest confidence score. We do few-shot prompting. We provide some examples of categorizations that we have done with previous listings. And at the end of the prompt, we provide the long description, the array of features, the array of use cases, and then some requirements. We tell him to only select one category and to not invent new categories. We need to use the provided ones. And we see the final prompt for the brainfish listing. And for the output parser, we want an array of categories where each item should have an ID, the name, and the confidence score for that category. Here we are asking for an array of features, but we could just ask for a single input. We have this merge block where we are merging both the category that the LLM has output and then the categories that we have in our database. So now the reason we are merging this is because we want to do a sanity check. In the end, LLMs are not deterministic, so this is very important when building these systems. You want to have some kind of sanity check. So we'll be using custom code, and we are trying to find if there's a category within this array that matches the name customer support, and then we take the ID from this item. We are not doing it the other way around because I said it could be that this ID that the LLM provided doesn't match the ID that we have in the database. That's why we want to work with the source of truth as much as possible. And now with this category ID, we could proceed to link the listing ID with this category. But since we have this branch above this branch over here, in N8N, the way it works is the branches that are above get executed first. They just follow the normal path of the flow. And here in this next fetch request, we are retrieving the tags from our database that are used in this category. This is a function we have defined in our database. What we are passing as input parameter is the category name, that it would be customer support. And okay, we only use 3 tags. So now with these tags, we can proceed to merge the general information of the agent with the tags. We provide this to the LLM, and we tell the LLM to assign up to 3 relevant tags. We do few-shot prompting with the description, use cases, and features. What we see is that it detected 2 tags, one for customer success and one for call center. And if we have a look at our directory, when possible, we assign only 1 tag. We don't want to oversaturate the listings with tags. We just want to select the most appropriate ones. Okay, so with information, we can proceed to contrast the tags. We are merging again the tags that the LLM provided with the ones with the database. Here we are using similar code for contrast the output of the LLM, but we filter the tags and we only take those that have a confidence score of 0.9. So as you see, the one for call center that has a confidence score of 0.8, quite low for our standards, we will not insert it in our database. So now we have the tag for our listing, that it's customer success, and we have the category, that it's customer support. We can proceed. We take the general listing ID from this node, we merge it in this code over here. We do some pre-processing of the data just to have it in the structure we want. Actually here we will only need the ID of the tag and the listing ID because we follow the same pattern as before. We have a table to associate listings with tags, that it's called listings tags. We just need the listing ID, that it's this one, and then the ID, that it's over here. We see that the insert operation was performed properly. And we can do the same for the category. We merge information with the IDs. We prepare the data to be inserted in the database. Out of these 4 inputs in the node, we just use the listing ID and the ID of the category, of the customer support category. So now we have the listings in the database, we have the use cases, the features, the pricings, and with this last step, we have in the database information about tags and category assigned to the listing. So with all these steps performed, if we could stop the flow here and go to the directory, we could see that all the information is there, but there would be no image for the listing. This is the last step of our flow. We are taking the image URL that we provided in the first step. We are downloading the image, we're inserting this image in our database, and finally, we're updating the listings table with the public URL that we have in our storage database. To do that, we'll be using another flow in N8N that we have defined over here. Let's save this. It's this one. So here it accepts an image URL parameter. If we go to the HTTP request, we can fetch the logo. What we have is an image that is this one. So this is the cool stuff of N8N, is that it allows you to work with images. We have some metadata like the file size, the type of image, it's PNG. So if for this merge node, we see that here at the bottom we have a custom code. It's quite large. So here what we are doing is just extracting the extension of the image, where it's PNG, JPEG or SVG, the dimensions, and also the file size. Bear with me and you will see now why we are doing this. So we merge this information. And here we see the width, the height, the size, and whether it's square. And the reason we are doing this, it's because in our directory we only use square images, because otherwise they are not properly displayed. And then since these images will be uploaded in our storage bucket, we want these images to be less than 50 kilobytes, because otherwise this could affect the site performance. So if we don't manage to fulfill this criteria, this workflow will just throw an error and it will give a message saying that the image is not squared or greater than 15 kilobytes. Otherwise, we'll just merge the image URL with all the previous information. And here we'll just do a post request to our Supabase storage bucket following a certain format. This field will be provided in the main flow. For this node, you will be also required to have a Supabase credential. And here we are using some cache configuration. You can ignore it. The important stuff is to enable the send body option and to send the binary file that we obtained in the previous node. So this is the flow that we'll be using to upload images to our database. Okay, so back in the main flow, we have the image uploader workflow that we have seen before. Here we are just merging and we see that we have all this information, but in the end, we only care about the image URL for the image uploader flow. But then we also care about the listing ID, because this listing ID will be later used in this block over here to update the listing with the new URL. Okay, so we have a look at the image uploader workflow. We see that we have successfully executed this flow and it has returned a key. This is the relative path where the image has been uploaded. So now we can merge this information. We have the listing ID and this path. Here in the Supabase, we can now proceed to perform an update operation on the listings table. We'll be looking for the ID of the listing ID, and then the field that we will be updating will be the logo URL. This is the path to our database storage bucket, together with the relative path that we obtained from the previous block. In the output, we see that this has been properly executed. Actually, if we paste this over here, we see that now this brainfish logo, it's in our storage bucket. Alright guys, I hope you enjoyed the video. If you did, please like and subscribe, it really helps a lot. In the next videos I will be sharing how we have built a real agent that does all this flow but using LangGraph. Also, if you're an SME looking to integrate AI within your operations, contact us at flowhot.com. We are here to help. Thank you and see you next time.